6 model families, 5 augmentation strategies, and 1 modular pipeline. Here is how we got there. Three constraints shape every decision: limited Kaggle input, restrict per question borderline, and very different topic categories. That is why we didn't build one fixed pipeline, like shared call with optional blocks for retrieval, math, audio, activated only when the question needs them.
We explore two dimensions simultaneously: model family and size. Across these 6 families, we tested models ranging between 1 and 46 billion parameters, building a dedicated implementation for each family. This matters because instruct and reasoning models have different chat template requirements and behave differently under the same prompt. Two boundaries emerge clearly. The majority of models below 5B consistently underperformed in comparison, regardless of prompt strategy, and reached a ceiling at about 25%. Models above 28B were too slow and too heavy for Kaggle hardware, so our practical window was limited between 5 and 28 billion parameters. Within that window, no family was universally best. Each had categories where it performed noticeably better or faster than other, so we went on with the best performer of each family. In the second round of the experiment, we tested 5 prompt strategies: 0, 1, and few shots, role prescription, chain of thought, plus a combination of those. The clearest finding was that COT consistently timed out on Kaggle hardware, and what looked like poor reasoning was mostly an infrastructure constraint. On a stronger machine with a higher token limit, COT worked incredibly well. For example, 5.4 on math improved from 20% to 34%. Still, math was the weakest category across all models and all the strategies at this stage. Without the COT pressure, though, few shot was the most reliable lever. Small models responded well to examples, and 5.4 reached 41% with just one shot. Generally, the prompt preference is family dependent. Some models prefer COT, other few shot. Some responded well to both. No single strategy was universally best. 5.4 came out on top overall and became our new baseline.
Based on our observations and the remaining tasks, we have decided to split the remaining work and to process in parallel. First, let's look at the more models. We studied with the role prompting, then tested a 4-prompt sweep only on the top 3. Role prompts seems to make things worse rather than better, which probably means more models need a different prompting style. But German is the best one of the group. It has a performance as 5.4 and especially faster on the task as mathematics. Then for experiments of ensemble voting system, under our hardware constraints, we decided to use 1 model for mathematics and 3 models in parallel for other topics. But it seems slower and less accurate than a single model, so the ensemble system may not be a good choice in our case.
For that, we tested whether and achieved the evidence for how fact-heavy Kaggle is. We started with Markov indexes, but the gains were limited because the static corpus can't cover fresh information, and the tuned context was often related but not decisive. In user rights, we moved to or non-retrieval, like DuckDuckGo and Wikipedia. Since each category has its own filler mode, we run separate tracks for each, varying source, ranker, champion, etc., ending with a topic router that dispatches each question in the best configuration.
Mathematics was a hard category, but not because the questions were complex, because language models hallucinate arithmetics. Our baseline set at about 4% accuracy, and we tested 3 main strategies: COT prompting with base models, a custom tool suite, and maths native models. Tools alone peaked at about 20%. COT was a strong model, reached 34%. But the clear winner was Gemma MOE with COT and no tools at all, at around 70% accuracy. The lesson? The right model mattered more than external computation.
For the speech mode, we tested 3 main methods: processing 1 audio file at a time, concatenating the question and options into a single file for 1-pass transcription, and using Gemma 4's native audio ingestion to bypass speech-to-text module entirely. Fourth approach, using Gemma 4 purely as a transcriber, was rejected due to severe latency. To handle noisy audio and automatic speech recognition hallucinations, all transcripts pass through post-processing filters that remove laughter, filler words, and repeating text loops. Ultimately, these speech processors cause a 10 to 15% performance drop, primarily because the models struggle to accurately transcribe domain-specific terms. We built an agent that competes across 6 topic categories on limited hardware. The final pipeline combines Gemma 4 26 billion as the base model, topic routed the retrieval with Wikipedia and DuckDuckGo for history and news, with a re-ranker on top, math tools with chain of thought reasoning, and full audio support through a dedicated speech processor. The clearest lesson we learned is that there is no universal solution. The system works because it adapts, and that LLMs are really good scriptwriters.